this is nothing but 1 into dt. So anything power 0 is equal to 1. Let us have t power. Displacement is indicated by S, and this displacement is nothing but, let me consider position A, position B. Okay, so from this position to this position there is a displacement, and that is represented by S. And actually we can call it S1 and S2. These are the positions. So the infinitesimally small difference is called displacement, that is instantaneous displacement, that is ds. So ds means the displacement element or instantaneous displacement, and that occurs in short interval of time. Short interval of time. Take down. Therefore, velocity is nothing but ds by dt. Okay. So this is called velocity. And the acceleration means change of velocity divided by time. That is v minus u divided by time. And we can represent this as v2 minus v1 also, the change divided by time. And when it happens in short interval of time means that is the dv. So in short interval of time. So acceleration can be represented as a is equal to dv by dt. Right? And this displacement can also be represented as in terms of integration. For example, v into dt. And this v is nothing but ds by dt. So the velocity can also be represented as v integral a of dt. Now this a is equal to, as we already discussed, dv by dt. So we can integrate on both sides. Integrate on both sides. So it means with respect to time. With respect to time, t. So a dt is equal to dv by dt into dt. It means integration of dt is equal to t, because when I say dt, this is nothing but 1 into dt. So anything power 0 is equal to 1. Let us have t power 0 is equal to 1. Therefore, t power 0 is equal into dt. So on integrate, so this can be interpreted like this. For example, let us have the formula x power n dx. When you integrate, you will get x power n plus 1 divided by n plus 1 plus integral constant. So let us apply this, and this can be cancelled. So a can be taken outside the integral. So a of dt is equal to integral dv. So let us apply the same strategy here, a, and this becomes what? That is t, because on integration it becomes a t, because t power 0 dt means t power 0 plus 1 divided by 0 plus 1 plus integral constant. That means t. So that is why you can simply put t, and here this becomes v, and this happens between, that is a u and v. Okay, so in that case this becomes v between the limits u and v. So final velocity minus initial velocity. Okay, so that can be represented as final minus initial, and this is at. Therefore v is equal to u plus at. So this is the first derivation. Similarly, we have second equation. Yes, as we already discussed, this is v into dt. So s is equal to integral v into dt. We know already v is equal to u plus at. We can substitute this. So s is equal to integral u plus at into dt. This can be expanded as integral u dt plus integral at. Okay, so we know already for dt it is t, so we can put u into t plus, and for this we can apply the formula. This is a t into dt. So you can keep outside the integral a being constant. And what about t? So integral t is of dt is equal to t power 1 plus 1 divided by 1 plus 1, is it not? Therefore it becomes a into t squared by 2. Okay, therefore s is equal to ut plus half at squared. So this is the next equation. Do you understand? Now the third equation. We know already v is equal to u plus at. Squaring on both sides. So it becomes a v squared u plus at the whole squared. We can expand. So v squared is equal to, apply a plus b whole squared. So u squared plus 2uat plus a squared t squared. Got it? We have got already s is equal to ut plus half at squared. Right? So we can expand this v squared as u squared plus, and this we can divide by 2a. Take the GCD. So take outside the bracket. So it becomes 2uat divided by 2a means 80. And this one is 80 squared divided by 2 because we have taken 2. Are you able to follow? Therefore, v squared is equal to u squared plus 2a. This is nothing but s. Is it not? This is ut. Therefore, yes. So we can apply, we can derive like this the next equation. Are you able to follow?
Why are we dividing by 2a?
In order to get this ut plus of 80 square.
To get
So that we can replace this s is equal to ut plus of 80 square. Right? Now we can have the displacement in nth second also. Let us proceed. The displacement that takes place in nth second, that is after nth second. Displacement after nth second. What is SN? Displacement after n seconds. It means nth second. Displacement in nth second, or it can be called displacement after n seconds. So Sn is given by u into n, that is nth second, plus half a n square. Instead of t, I have put simply n. Now displacement after n minus 1 second. So this is displacement after n second. For example, let me say first second, second second, third second, fourth second, like that. Let me consider sixth second. It means I have to consider this sixth second. After 6 seconds means this one. And just the penultimate one means 6 minus 1, 5. So let me consider n. And what about this penultimate second? N minus 1. So let me consider s n minus 1. It means displacement after n minus 1 seconds. Okay. So Sn minus 1 is equal to u, instead of n you can put n minus 1, right, plus half into a n minus 1 the whole square, right. In fact, the Sn is nothing but the displacement that takes place in after n seconds minus Sn minus 1. Okay, this should be represented in small letter, and this should also be represented in small letter, and this is capital letter. Okay. So Sn is equal to Sn minus 1. So that means if you want to analyze in the nth second means, let me say this is Sn, this is Sn minus 1, and the nth second means that is Sn minus 1. That is nothing but Sn. Do you understand this? That's what I have taken here. So we can apply the same formula. Sn means, let us substitute Sn is equal to what is Sn? Un. This is first equation, this is second equation, this is third equation. So substitute, that is 1 and 2 in 3. Therefore Sn is equal to what? Sn is equal to un plus half an square minus, and what about this, u into n minus 1 plus half a into n minus 1 the whole square. Okay. Now let us further proceed. Let us expand it. Sn is equal to u into n actually, u into n plus half a n squared minus u n into u into minus 1. So this becomes plus u. Do you understand this? Minus into plus minus. So let us further expand it. Half minus half into a into n minus 1 whole square. Let us further expand. So un plus half an squared minus un plus u, now minus half a into, let us expand this, n squared minus 2n plus 1, right? Therefore un plus half an squared minus un plus u minus half a into n squared, and then minus of minus plus half into 2 1, therefore an, then minus half a. Got it? Okay. Now we can cancel un half an squared minus half an squared, right? Now we can write the remaining. Therefore Sn is equal to, what is this, u, and what about this one, minus half a plus an, right? Okay. Now in both cases we have got a, right? So therefore u plus a can be taken outside the bracket, therefore, and n you can bring it here, so minus half. Okay. Therefore Sn is equal to u plus a into n minus half. So this is the nth hour displacement. So displacement that takes place in the nth second. Okay. Got it? Any doubt?
ஸ்கூல்ல இது வேற வேற மாதிரி போட்டிருக்காங்க.
You can take this.